Hello and good evening, everyone. Our speaker for today's Student Alumni Meet is Ms. Sanhita Pal, who graduated with bachelor's degree from the Department of Metallurgical and Materials Engineering at the National Institute of Technology, Durgapur in 2020. Subsequently, she completed her master's in mechanical engineering at the University of Alberta in 2020, and currently she is a graduate research assistant at the University of Alberta and has worked on robot-aided thermal spray coating manufacturing, material selection and characterization, heat treatment, sustainable manufacturing, project management, data analytics, atomistic simulation, molecular dynamics, finite element analysis, and machine learning, only to name a few. She obtained and pursued prestigious internships at IIT Kharagpur, University of Alberta through MyTech Scholarship, and the Max Planck Institute. We are truly grateful to have you among us today, Dee, and I kindly request you to take over the session.
Hello, am I audible and visible to all of you? Yes.
Yes, Didi, you are.
Okay. Well, hello everyone. So thank you, Care, and all of you for inviting me to share, say, some of my story or just share my story with all of you. So it means a lot, and it feels really good whenever one of the juniors contacts and tells that, okay, we want to organize something like this. It's amazing, and I would like to congratulate all of you for all the efforts that you put into for organizing these sessions. You guys have been doing a great job. I believe you have been doing it for the last 1 or 2 years, and it's going amazing. So keep it up. And thanks to all of you for joining this session. I know it's a Saturday evening, and this speaks volumes about your interest in your career and the future. I guess that's why you're spending your Saturday evening doing this. So kudos to all of you for that. And I was hoping this to be more of an interaction session where we just interact. You ask me your questions, your doubts, and I'm going to give you some of life advices maybe, and some suggestions and things, and share with you the things that I have learned during and after NIT Durgapur. So, and I would really like if some of you could turn on your cameras. That's really good, and I can see some of you to actually talk to. Otherwise, it's just few alphabets out there. And I have prepared a very small presentation for all of you. It's like really brief to discuss this thing, so I would like to share that and tell you like literally about what the topic said earlier. And again, thank you very much for the wonderful introduction. So you guys did a good job pulling up stuff from probably my LinkedIn profile. So thank you for that. And I'll find the share screen option somehow. Okay. Window. There I go. And here it is. Sure. Awesome. Great. And so, are you guys able to see things in the proper orientation?
Yes.
Yes, Didi, the slides are visible.
Okay, so you see the presentation slide, or do you see the other one? I have no idea. Wait. What do you guys see right now? Do you see my notes as well? Oh, man. Hello.
Yes, your PowerPoint screen, what I do and other things. University of Alberta.
Oh, yeah, right. You don't see my notes. Awesome.
No.
Great. So you have already given my introduction, but what I do. So I graduated from metallurgical engineering in 2020, and following that, I started my Master of Sciences at the University of Alberta in the Department of Mechanical Engineering in like fall 2020. And right now, like, I defended my thesis a couple of weeks ago, and presently I am totally in the job hunting mode and still continuing to work as a research assistant at the university for a while. So here I have assimilated a few pictures of, my university, my lab colleagues, and that's it. Next, what I'm going to share with you all is a short video of what I actually do in my lab, or how it looks like. So I'll just pull that up for you. Oh God, this mouse doesn't work. Oh man, sorry. Okay, I have a small problem out there with my orientation, and I am really sorry. I don't know what screens you're seeing, but it works. Okay, so here is the small video of my lab to give you an understanding of what I actually do, or what grad students do in research.
Excuse me, ma'am, your video is
Yes.
not visible.
My video is not visible. Okay, thanks for.
No, it's visible. It's visible actually.
Okay, sorry. Then my internet is
Yeah.
Okay, no problem. I'm so sorry.
Excuse me, ma'am, are you showing something? Because we are not seeing anything except your PPT.
Hi. Okay, wait. I need to fix this. Where is the thing? Wait, what do you guys exactly see?
Your PPT screen only.
And you don't see the video?
No, actually means while choosing the presentation mode, you will be having some things like a tab, a window, or the whole screen. So there you need to choose the thing.
Yes, I do realize that. Okay, this is one of the reasons I hate Google Meet, because I'm unable to see anything that I'm doing. I'll try something. Wait. Oh God. Okay, give me
You
a
may stop.
moment.
Yeah. Yep.
Sorry about that, guys and girls.
No, it's okay, man.
Okay, wait. If I turn this thing off, it might be of some help. There you go. Turn off. Oh man. Okay. Let's see if things are working now. Okay. Do you see things now?
No.
No, man, it's not visible.
Okay, wait. Oh, Google Meet, I hate you so much. Yeah, window. Okay. That should be good. Share. Now, please tell me yes. Do you see things?
Again, the same PPT screen.
Yes, exactly. Okay, now this. Just let me know if you can see the video. Hello?
No, ma'am, the video is not visible.
Okay, I guess the video won't work, so I'll show you the video separately. That's bad to send. Never mind. So the video is right here. Plus, it's green and oh gosh. Oh man.
Your screen is blank, Deep.
Yes, I realize. Just a moment. And enter screen. Should be good. Screen 1, screen 2. Screen 1. Share. Yes, now I believe you all see this thing. Is the video visible to you, all of you now?
Yes.
Yes, it is.
Okay, finally. Really sorry about that, guys. So this is a short video of my lab. Like most of my research is experimental where I do stuff. So this is a short video showing what I used to do, and you get to see a different kind of thing. So I work on thermal spray. It's a coating process, and generally this is how the coatings are done even in the industry. So I thought it would be a good idea to show you how the process works. And okay, oh god. All right then, finally I managed to show you all of you the video. So what I wanted to show you all is that, okay, I work in surface technology and fabrication of coating. So thermal spraying is one of the many processes of coating, and primarily this kind of coating process is used in your the aerospace sector, the oil and gas sectors, and in your gas turbines. So these are some of the primary areas where this coating technology is used to produce your most importantly, things like thermal barrier coatings. So those of you in mechanical might be aware of your turbine engines and what the role of this TBC or thermal barrier coatings can be. And for those who don't know, this kind of coatings, it's used for thermal protection. So that allows the turbine to operate at higher temperatures, thus increasing the efficiency, and they have really great importance in this sector, especially your the aerospace and the power generation sectors. Also, these coatings are used for protection against wear, corrosion, and erosion. It's very well established, pretty old process, and kind of well established on the industrial scale, and doing fairly well. So my entire research this time focused on developing these coatings using a new material, like not really new, it's high entropy alloys. Again, I'm not sure if all of like you have heard about it or not. I guess you did, some of you, and many didn't. So high entropy alloys are, well, they have been trending for the last decade or so, and it kind of is very fascinating because conventionally we think of alloys as just like one primary element with a couple of more additions. But then again, this high entropy alloys changed the entire concepts of alloying, and now we have like multiple principal components. It's like just mix for 5 elements or more than those together, and then you have an alloy. And oh my God, they can have really very interesting properties. And the best part about them is that you can use all of the computational techniques and your machine learning and artificial intelligence and stuff like that to cook up and design alloys of your choices, and to figure out literally make alloys to meet the requirement of niche applications. So my master's project focused on the development of this high entropy alloy coatings using thermal spraying for de-icing purposes. I wish this interface was a little better, but never mind. Okay, I'll try to share my screen again. And okay, share my screen, present now. Whatever it is, share. Okay. If I minimize this, I get to see. Okay, I am not even trying to switch into my presentation mode, and I will just hop on to my next slide right over here. Okay, so this is what my research is on. High entropy alloys, thermal spraying, and de-icing of coatings. Now guys, I live in Canada, where winter starts as early as September, and in most places continues up to like 8 months. And for us here, that where I am living, temperatures can go as low as minus 40 degrees Celsius. And so with minus 40, you can imagine there would be a lot of problems associated with icing and related stuff. So the bursting of our water pipes and the icing of our, say, wind turbine blades or the aircraft blades, they are a very common problem over here. So my goal over here was to develop this kind of resistive heating coatings, which would enable melting of the ice. So what the goal is, it's like you coat this blades with heating materials, like resistive heating materials. So I believe all of you are aware of the heating element materials like nichrome. So we basically coat these, and then we apply some current to all of them, so that there is this heating by Joule's heating, which all of us are aware of, and which helps melting of the ice. So there I am. And that was the entire goal. I used high entropy alloys as my materials because this is, well, something new, some properties which has not been explored. Mostly people focus on exploring like the mechanical properties of these alloys, and they do have proven to be very strong, have high hardness, high strength, and many other interesting properties. However, people have not yet explored the other properties like the electrical or say magnetic properties, which are fairly unexplored for these materials. Then we thought, why not try the other side and explore and see if these materials which have so good mechanical properties can have some viable functional abilities too and could be used. That was the entire purpose of my work. And I honestly wanted to figure out if these materials which are
Sorry
so
to interrupt,
trendy.
Judy, but there's the window blocking your
Okay.
presentation, the minimized window.
Wait, just a moment. Stop presenting. No, wait. Yep. Okay. Thank you for letting me know, and I am really screwing up Google Meet. Sorry for making this such a terrible experience for all of you. It's really terrible for me as well. I don't know what's something weird about Google Meet. I never use it. I'm really sorry for being so technologically handicapped with Google Meet. And so where I was, then I finally decided to test these materials, the high entropy alloys, and see, well, let me check out if the hype is worth it. Is it going to be the future
Didi, your
material?
presentation is invisible.
I'm not showing anything.
Okay, please continue. Sorry to interrupt.
Thanks for that, though. So yes, is all this, like if any of you are interested in research or things like that, this is like really trending, and it's worth investigating if it's worth all of that. Because does it have the capability to replace our present material? Is it so good enough that it will be a good competitor for your steel, which we have been using for decades and is still here, or your Inconel, or your other alloys which have been there? To be very honest, it has just been conceptualized, and the most fascinating part is that the professor who came up with it's literally like alchemy, and somebody used their imagination and exploration and came up with this thing, and it turned out to have good results, and now most of the world is exploring it. So in India, the research group led by Professor B.S. Murthy at IIT Madras, they work on high entropy alloys and also on thermal spring. I know that thermal spring is not very popular in India. Like back when I was there, I didn't find it to be very popular. So when I came for my internship to learn about this one was fairly new to me. I know the coating processes that is more popular are the CVD and the PVD processes, which people research on. So this is something more from the industrial perspective, thermal spraying. You can search about it if you're interested to know. And the other part was the high entropy alloys. So now the question is, did I achieve my end result? Did I achieve my end goal to test whether my material can melt the ice? Well, good news, I did. I also end up comparing my high entropy alloys with the traditional nichrome to see, well, let me see if it's good. Thankfully, and the best part, it did turn out to be better. It gave good performances compared to nichrome. And now the next phase of research would explore the practical feasibility of these materials, if they can be actually practically used. Now in the lab and in theory, a lot of things are possible. But when we want to implement something on an industrial scale or a practical basis, it's very difficult to get to that. So a lot of our research remains restricted to our labs and papers, and let's see where it goes and if we will have a new material or not. And the next part of my presentation was to share with all of you some of my learnings about career in general, and help you guys to plan and give you a better picture of the present state of academia and industry here in Canada, and whatever I know a little about India that I know from my friends, because for the last 2 years I believe India has progressed a lot, and whenever I read about things in news and I see things and where we have come, it's like we have come a long way, and I am very proud of my country. I'm very proud of NIT Durgapur and all the things that we have been doing. So now, the thing is, when we were in our second year, third year for sure, and of course final year, the question was, where do we go after undergrad? So can I just get a quick poll of like which year all of you are in, like first, second, third, just a rough idea. Then I would be able to answer your queries better, and I'll formulate my talk accordingly. So yeah.
Combination of second, third, and fourth years. Final year, pre-final year, and second year.
Oh yes, I do. I was expecting that. So anyway, that's fine. Cool. So thank you for again sharing that. But okay, never mind. Now, so the primary question, I believe all of you have in your mind, it's like, do we go for academia? Do we go for industry? Which one would be better? Which is, I don't know, maybe more secure? Which one would I like? These are questions which we had when we were in your place, and our only way, so the best part that you guys doing right now is organizing these things where you bring in people from the different sectors and you actually interact with them. That way you get to learn from them, their experiences, their life, and it helps you make more rationalized decisions. So what I'm going to tell you about grad life in general, like here in Canada, and what are the perks of it, what are the not so good things of it, and also give you a brief picture of the industrial thing here at Canada. Now, I don't know how many of you are interested in research. Some raise hands, some high maybe. And to be very honest, if it's possible, turn on your cameras. Okay. I see a lot of you over there interested in research. And can I ask one of you, what makes you interested and why do you know that you really like research? Or one to just share your experience. I would be happy to hear it. And it's okay if you keep your cameras turned off, just speak. And I believe it's all of your friends and your colleagues out there. So don't be nervous, just share your thoughts. Why do you like research?
I find the reason for which I am interested in doing research is because I find research is the only way through which I can do something better than the rest of the people, because everyone is doing the job and other things. If I do research, then the job will be in my hand for sure, and I will be doing something else apart from the job. So this is the reason. And yeah, this is the now this is the only reason, but yeah, on later stage I will have more interest.
Well, thank you, Nasir, for sharing your thoughts. Can I just ask you, what are you researching on right now? Or which year are you in?
I'm in pre-final year, and I'm doing research on the civil engineering topic in our branch.
Okay, that's amazing. Well, I like your thoughts and I like your passion for research. I do get it. And well, good luck. And I'll share some more things with you. And hopefully you will be able to figure and get more clarity. Next, who wants to go next?
Thanks, man.
Didi, I think
On the
that
behalf of me, that go on. You want to?
no, you go ahead.
No, you can continue.
Okay. So on behalf of me, actually being a chemical engineer, that I think that in past that we produce so many petroleum products and biochemical products, etc. But we also do lot of pollutions. And on the current scenario, we should maintain the we should thought about the sustainability, because if we don't think like in the coming decades, everything will be out of control. So being doing some projects under the Dr. Tamal sir, and in wastewater management, and also getting some projects from another professors in the optimizing industry things, like by optimizing the CO2 productions, and also there is also a trade-off between CO2 and energy optimizations. So I think so that we should work on sustainability, because and also everyone is thinking about green oils. So that's why I think I should work on the research part, so that I can develop something more.
That's awesome. Thank you for sharing. And I really like your thoughts on sustainability aspect. We should, as much as possible, from personal to professional levels, work for it. Because if we don't take care of the environment, it is going to go crazy. You know, the best part is that we don't feel the effect of climate change to that extent near the tropics, in India or back here. Over here, we feel it, and it's crazy over here. Places over here never had temperatures beyond 25 degrees Celsius. This time we have temperatures around 36 degrees Celsius in summer, which is wild. So climate is changing, and all of us need to take some responsibility and play our part to reduce the change. And it's sustainability and these things are something that we should work on. So look for projects and works related to that, and try to contribute and make some difference and changes on that aspect. The world needs you, and your future generations will be indebted to you for that. Anyone else would like to share why they like research?
I would say that when we are researching or exploring new frontiers, we may find new applications of substances or techniques that we didn't previously know. And I think that this actually increases the job market. So that's my motivation
That's awesome.
for going into research.
That's great. That's awesome. And now, anyone over here interested in the industry?
Good evening, ma'am. May I have a word with you?
Sure, of course. Go ahead.
Yeah, I'm from third year civil department in NIT Durgapur. My name is Manak Makkale. Very pleased to meet you, ma'am. It's absolutely lovely to hear from you. It's amazing. I am quite a bit interested in joining the industry as a part of the team of professionals that is going to drive the process forward. I kind of have a comment, and at the same point I have a sort of question for you, if you don't mind. Would you be fine?
Go ahead.
That would be lovely. I understand that there are. I have this thing. I feel that pattern spotting is very important in any sort of progress in a technical field. Like at the end of the day, everything develops from developing and understanding patterns. I have been really fascinated with this understanding of how structures grow, because with this understanding of civil engineering, it kind of grows through with it. Have you had any experience working with people who have successfully maintained a career in analysis and the mathematical, structural, physical part of civil engineering while maintaining a career in industry as well? Has that been something that has been very familiar with you, or is it something that is unheard of?
Well, to be very honest, it's not very familiar with me, the entire pattern thing and everything. To be very honest, I do not understand what you are telling. To me, I don't have a lot of, yeah. Okay.
I wanted to say that there are aspects of research which concentrate entirely on the practical aspects of things, and then there are theoretical sides of things which develop on patterns spotted in the mathematical aspects of things. Then is there any example of people working in the industry who have successfully maintained a theoretical research career and have also done well as industry professionals? Have you seen anything of that sort?
Okay, not yet. And no, I mean, not from your civil department that I know. And then considering this, from whatever I know until now, the theoretical research. So what you mean is that merging the theoretical research with having a career in the industry. Do
Yes,
you
yes,
imply?
exactly.
Yes. So I believe you're implying somebody who is working in the R&D in an industry, but working on the more theoretical aspects of projects
Exactly.
and not the practical usability. By theory, do you mean that they are focusing on, say, the like what comes to my mind is, say,
IBM
like,
used to have people like that involved in their like Benoit Mendelbro was with IBM for several years, and they had a core of these theoretical researchers in their company. I don't know if companies are still doing that. That's all my.
okay. So now look, it some of the larger companies, the bigger companies, like you mentioned, the IBM, and then there are this huge companies who do have a very big R&D team. They have different kinds of team, and theoretical research, well, at the end of the day, all kind of research needs to be sponsored by some or the other organization. It has to be either the government giving the funds or either the companies or industries
Yeah.
giving you the fund to carry on your research. Otherwise it's impossible to go on with that. And now the basic question is, why would the industry or the government be interested in funding your work? That is something which is very important. The thing is, your work needs to have a practical feasibility, or if it's a theoretical work, that theoretical work, say simulations or things like that. A lot of people work on, say, the CFD, that's what's coming to my mind right now. So they work on more like the physics or simulation purpose. I'll give you an example from my work. So I was working on this flame spraying thing where the torch is moving, the flame is there. Now there are a lot of simulation studies and theoretical studies which are involved. The very designing of the torch or the nozzle, or how the flame is going to go, where I need to insert the powders, where I need my gases to be flowing, all of those comes from the theoretical work or the simulations that we do. The designing of that torch, which is a practical application
Yeah.
of the many theories that we have heard. There are theoretical equations and stuff related to welding. So this guy in 1950s, he worked on developing just the models, and then we'd be like, why do we need all of these models? But those models developed in 1950s are the very basis of the things that are working in the industry right now. They are not ideal in simulating the situations, but they do. So I'm sure the companies have a certain section devoted to this extremely special research for working on the theoretical aspects of things. And if you're going to the more theoretical aspect, like the physics point of view and stuff, of course there, you know, that their places exist. And if you want to ask me how much of that is there, well, I am not entirely sure, and it's kind of hush secrets that companies keep. And until and unless you really are inside the company or a
Yeah.
part of one of those teams, it's very difficult for you to find out. They don't like to share your secrets. They just share some stuff which are already known to people.
In public domain. Yeah.
Yes, exactly. And why would they? They wouldn't like to
Yeah.
lose to their competitions and stuff. So, my friend, right now, I don't have answers. If ever I do and get a more quantifiable answer for you, I'll share that with you.
I would be absolutely delighted if one day I could get that answer to that. Thank you so much, ma'am. Thank you so much for
Yes,
honoring me
no
with that.
problem. Thank you so much. I'm glad to see so many of you interested in research, and you, I believe, want to join R&D in an industry. Am I right?
Yes, ma'am. For the most part, it kind of is really enticing for me to think of myself in such a position. Yes.
Yes, that's awesome. That's good. I'm really, because we are studying, we are learning, and one of the best ways where I see we could apply all of these learnings is the R&D of the
Yeah.
industry. And
Definitely.
so, well, very good. I'm glad all of you
Thank
are
you, ma'am.
looking into perspectives. And any proponents for just job and industry, not the R&D side? Anybody? I guess not. Okay, never mind. It's okay. So, well, what I learned after moving to Canada. So when I was in third year, I was like, okay, all I'm going to do is research. I will do my PhD and then I will join the R&D of an industry. And I was so sure about it. So then I thought, okay, let me begin by doing a master's. I did have a couple of good internship experiences back when I was in college, and then I just decided to pursue my master's. I was very much blindsided. It's like I did not even think of exploring the industry right then. Then I came here, I looked into my master's, I interacted with a lot of people, got their perspectives, learned more about the industry, the practical applications, then the implications of how the world is actually working, what's driving it, who funds my research, where my research is going, what's the purpose of my research. I learned all of those things, and then I just realized that, well, industry is not too bad at all. And maybe it's a good idea to explore the industrial part as well. You know, now that you guys are starting out on your career, I urge all of you to look into both the academic side and the industrial side. So if you have done one of the research internships, try to do another internship with an industry, with a I don't know, with one of the plants. See how things are working. Talk to the managers or talk to your seniors who are there in the industry. Figure out, because at the end of the day, what research we do during our undergrad, to be very honest, it's just the tip of the iceberg, where the world seems very rosy and there is it's very interesting. But when you actually have your own project to deal with and you're looking into things, you're spending years on it, you realize that, okay, maybe there are other things to look into, and maybe it is not that new or that you know, I mean, the thrill of it can die out sometimes. So you might get bored with the thing and you might feel stuck with it. So it's my urge to all of you to explore both ends, and more importantly, explore yourself, what your likings are and what you would like to do for the rest of your career. It's okay if you don't know what you want like now. This is the phase where you get to figure out what you like and what you don't like. And my friends, it's very important for you to do what you like. So otherwise you will be in such a kind of situation where you're just doing things for the sake of it and not enjoying it, and then life at all, it becomes very meaningless and frustrating. You won't be happy. So to be really happy and enjoy your career, take the time right now to explore your likings, your passions, your choices. And right now, all of you are too young to figure out exactly what you would like to do. And this will keep changing over time. Maybe you would like to work on this right now, and then after a while you want to work in this and that. And it's okay. It's okay to have multiple career choices or multiple career changes. But what is most important is that you should have some sort of a plan ready for you for the next 2 or 3 years of what you would like to do after this is over. Because you know, like our college, NIT DGP, I don't know what your thoughts are on. When we were back there, we used to constantly be like, oh, this is not there, that is not there, this is not working well, we don't like how things are. After we graduated, we all love NIT DGP and we are so thankful to you. Guys, listen to your teachers. They are really amazing. What they teach you at NIT DGP, they do prepare you with a great knowledge to deal with the world. And all of you are really, really amazing at those things. So learn whatever you are able to from your teachers. They work, I mean, they teach really, really well. Your course content, course material, it is take the word from me, it's pretty much at par with other top institutions in India, and even abroad, wherever you are, you learn the same kind of things, and your knowledge is like you're really equipped with most of the knowledge. So don't have thoughts like you're missing something or you're lacking something. Grasp it, make the best use of what you are being taught, because you're going to find great applications of those things. Work on the basics, learn and remember, I mean, like, not remember, like, try to get an understanding of all of it. One thing which I am not in favor of are the kind of our examination models or patterns, which is more like based on rote learning. Well, I don't like that. I hope they work on that thing. I don't know if it has changed a little or not. But the group projects or the lab works that you do, those are the things that you would need once you're out of college. So lab works are very important. Get to the lab, learn whatever you can, get some hands-on experience on things. It helps you. Even if you're researching just on the theoretical aspects, my friend, go and see how that machine is actually working. Touch it, feel it, and get an understanding of your concepts. It's okay if you don't aim for the highest marks or stuff. It's not important. What is important is your understanding of the things. That's what you're going to use once you are outside this. So I really urge you all to listen and explore as much as you can. And these days, a lot of fantastic resources have developed thanks to COVID, online learning and things. Like, mostly I can speak from the mechanical or metallurgical or even the chemical perspective. So if you are learning about your how a certain thing is working, go to YouTube, watch the video and see how that thing is working. It will help you remember better. It will help you understand the things, and you will actually have some questions, and those questions are very important. Keep asking questions to yourself, to your friends, to your teachers, and think about things. So if you are really interested in research, you should be able to ask questions on things. And right now, what I would suggest to all of you is look into like read as much as possible and explore stuff. And next,
Ma'am, I had a small question, if you don't mind.
Yeah, sure.
Ma'am, you did your master's in mechanical engineering at Alberta, but
Yes.
you did your bachelor's in metallurgical engineering. So how did you make the shift between the two streams?
Yes, so how things work over in most universities in North America is that usually the materials and the chemical department is often a part of the larger mechanical department. Most of these universities have four major departments, like the mechanical, electrical and computer sciences combined together, then civil, and then they have some materials, chemicals all together. So a lot of professors in mechanical actually work on the materials aspect. My professor, he focuses on heat conduction and heat transfer in general, but he needed somebody who would work on the material aspects of the projects. That's why he hired me, and my work was more focused on the materials aspect. And regarding the transition, it wasn't very difficult. I did have to take up coursework in mechanical, and I was very scared that, oh my god, I don't have a bachelor's in mechanical. How would I cope with grad courses? I told you, NIT DGP teaches you well. So whatever my professors in MME taught me, it equipped me enough to tackle the courses that I had here in mechanical. That's how well we are taught, and it's very easy for you to be at the top of your classes here. And trust me, ask all your seniors who are in academia, they are always at the top of their classes. That's how a good NIT DGP prepares you. So don't be scared. If you want to switch fields, over here people believe a lot in collaboration and working. A lot of your core field guys are actually in computer sciences. They have their bachelor's in electrical, but they are doing their master's in computer sciences, and it's not difficult, and switching and intermingling, it's what they are looking at. There are collaborations with the different departments, and everybody is doing their part. And so if you want to switch your fields, just equip yourself with the basics of those fields and you will be fine. That's something, again, you can keep a note of. So
Thank you, ma'am. Just one more question, if you would allow.
Sure. Yes.
Ma'am, since your research is heavily tilted towards machine learning and computational statistics, what sort of softwares would you suggest to the BTech students, irrespective of the branch, so that they excel in research, particularly
Awesome.
statistics part?
Yes. Okay. So firstly, my research is not heavily relied on computational or statistics. Those are things that I did in one of my internships. And statistics, to be very honest, everyone needs it. All of you needs it. So yes, coming to the next most important thing, I told that the next part is like gearing you up for Industry 5.0. So right now, we are living in this Industry 4.0 thing. So what is this Industry 4.0? Industry 4.0 is focusing all on automation, and machine learning and AI is a huge part of Industry 4.0. Now, what is Industry 5.0? Industry 5.0 is focusing more towards the sustainable aspect or the more human aspects of the industry, where it aims, like Industry 5.0 is coming, where it is aiming to create a better world for all of us. But it's far, it's not the onset. Right now, people are transitioning or trying to transition to Industry 4.0. And so when all of you graduate, or when we will be working, at least for the next decade, we will be a part of Industry 4.0. And to be able to make your mark and have a strong presence in Industry 4.0, yes, machine learning, artificial intelligence, data sciences, they are a big part of it. It's going there, and it's good that no matter what you are studying, you have a little background of all of these things. So all of us are taught about coding in our first year. Trust me, it's very important. It makes your life way easier. And concepts like data analysis, it's very popular out here. Not very aware of the present situation in India. Why is it so popular? What do people do? It's a trending field where, like over here, if you have a career in data analytics, you have like thousands of jobs. There is such a demand for that data analysis things out here in entire North America, and for computer engineers and stuff. So does that imply that we, the core students, have no not a bright future? It's not true. Core is here to stay. It will always stay. At the end of the day, if we don't develop the things for them, the entire computer industry is not going to survive. But we cannot ignore that the role that data sciences or machine learning is going to play. So it's regarding the software. Skill up. So learn about programming languages, Python is really, really trending. It's very easy to learn, and I urge all of you, share it with your friends. All of your friends, get a basic knowledge of Python. There are thousands of courses available. You don't need to know a lot, but just know how you write things, or if you have a code, you're able to understand most of it. Get those basic understanding, learn Python, because your softwares like MATLAB, and back in my undergrad, I used to work with LAMPS for molecular dynamics. So all of these things, they are related to Python. LAMPS was based on Python. So if you wanted to incorporate certain features in your program, and you know Python, that will equip you to be able to write that function or incorporate that feature, instead of having to depend on others or the existing ones to do it for you. So knowing a little bit of Python doesn't hurt. Then there are more practical concepts of statistics. Sad thing, we are not taught about statistics in great details. If possible, urge your teachers or take up a course on statistics for your elective, one of your electives, or learn just by yourself. It's incredibly interesting, and once you get into statistics, you will be just awed by the powers of what statistics can do. And it is the basics of machine learning. Don't be scared of machine learning or AI. They are not something that is like too hi-fi, or you will not be able to cope with. It's very much possible for you to learn it, and all of it is just based on your simple regressions and things you learn, and you go on developing it. Now, focus on your primary field that you're studying, and beside it, learn Python, learn how to do data analysis, because since most of you are interested in research, you will have a lot of data. And once you have a lot of data and you don't know what to do with it, or you don't know how to see it or present it, or what to extract out of that data, those data is useless to you. So this is and taking up this course on data analysis, it's for everyone. It helps the people who are interested in the industry, as well as those of you interested in research. You need to derive the information from that data. So learn how to do that. Next time when you do your lab experiments and you get the results, try to write your own observations and think what those results implies. Will take you a long way if you're really interested in research. And so what else? Yes, get up and start with your crash course on Python and data analysis. Do it. Next, one more thing that I wanted to tell you guys is that besides your studies and your theoretical knowledge, what matters are your soft skills. It is extremely important, whether you are staying in academia or you want to go to the industry. Your soft skills, your communication skills, the way you present your work is so very important. The world buys you only if you're able to sell yourself. So learn the art of selling yourself. It's so harsh, and sometimes it's really painful, because at the end of the day, we have to like literally sell our own selves, but that's how the world is working. So I want all of you to know that yes, you are good at things. You really are. Trust me, I know all of you are good at things. You can do things. But if you are not able to show that you can do things, then you will not get the opportunity. So work on your personal development skills. Grab that opportunity of public speaking wherever you get. Talk, improve your social skills, and learn to work in a team. It is very important. Don't be that kind of, I don't want to share, I'll do my project by myself, I don't want to look at it, yes, I'm the best, I'll just do stuff. It won't take you a long way. learn the importance of teamwork, and just work together. When you work together, you will be able to accomplish things really fast, and really new things are possible. That's something my masters taught me, the value of teamwork, and so many wonderful things just came out and so quickly. So work with your friends, collab together. Even if you are learning, do it together, inspire one another. And one more thing I wanted to share with you guys, because a lot of you are interested in research, it's that uh, depending on where or how you want to pursue research, like you want to stay in India, or if you're interested in pursuing research outside of India, you should be aware of other things. Okay, your professor, your project, your university, things are set, done. Then the other aspect is like things concerning your personal stuff. Like if you're moving to a certain country, you need to be very well sorted financially. Like at least you should know that how you're going to finance your higher education, and what are the things ahead of it, and what you want to do once you have you are done with, say, your master's or your PhD, like just having a rough idea. And there are also some of the downsides of a grad student's life. So things include, of course, the financial aspect. No matter whether you're in India or you're outside, all grad students are poor. Literally, you always are on the budget crunch side of things. You will be making less money than your counterparts in the industry while you're a student and you're researching. And in general, even if you are pursuing a career, say you're a professor or things, even then academia pays you way lesser than industry does. So if you want to make money or looking for things from that aspect, you want to get richer, then academia is not the exact way to get richer. And it's good that you consider and figure out what is more important. Whether you want, if you're interested in money making, then try some other ways. The best way, start your business. Even you'll get frustrated after a while in the industry. So think about that. What is more important to you? You want a fulfilling career where you want to be a scientist, you're aiming for the Nobel Prize or things like that. It's entirely different. You want to get rich, entirely different. So explore the things. And the difference between academia and industry is real. So it shouldn't come as a shock to you. So figure out what you want and eventually get to it. The other thing is take care of your mental health. It is very, very important. So what most of my friends over here and even I, it's extremely lonely, and it's once you move out of your comfort zone, your friends, your country, your family, and you're outside, your mental health and the related issues becomes tremendously important. We don't care about things like that. At least I didn't, and I never thought that it would be a big problem or it would affect, but those things really affect your well-being. And if you are not doing well mentally, it's very difficult for you to perform in your work. So if you are pursuing grad studies outside your home country, there will be issues with stress, anxiety, and loneliness, and that's inevitable. That comes with it. The perk side, yes, you get to travel, you get to see fancy places, you get to meet different kinds of people, you learn about their culture, and you're apparently working in the world-class laboratory, seeing things. These are the perk sites, and the sites which are often portrayed the beautiful pictures and the amazing harsh lives. But to be very honest, those are the top layer or the best part of it. Then there are the underlying layers where each day you need to take care of yourself, literally cook for yourself, take care of your work, ensure that you have enough rest, and maintain a proper mental health. So if you are thinking of pursuing academia outside your country, think about these things, and also think about the financial aspects. This brings me about pursuing a master's. So masters in most countries are not funded. In a few places you will be able to get partial or full funding, so look into that aspects. In some countries, or in pursuing a master's in some of the top universities can be really very expensive. And then so look into the budget things as well. And if you are doing a PhD in North America, it's fully funded. Places like Europe, UK and things, they are not even funding fully for the PhD. So look into those things as well, and think about everything. It's like where you would like to settle, and what you would like to do in the future, stuff like this. And honest search, if you're really thinking about research, try to get a hang of masters before jumping for a direct PhD, because a PhD is a very long phase of your career. It takes at least 5 years of your time, and if what you're working on doesn't interest you once you're in there, or you develop some other kind of interest. So if you're interested in research and you can afford some time, try to get a master's done. It prepares you better for your PhD, and it's very important. If you directly enroll yourself in a PhD, the first 2 years, well, that's kind of a master's that they make you do here. It won't be a very fulfilling experience. Again, try and experience some of the industry, so that you know that your what topic you're working on for your PhD, it's really important to you or would make a difference. So figure that out before you embark on all of these journeys. And what else? I guess that's all that I had to share with you guys. And so if you're interested in pursuing a master's here in Canada or a PhD, the way you go about it is you figure out the focus areas where you're interested in. Find out the professors or the research groups working in this fields. Then you usually write an email to the professors expressing your interest that you would like to join their research group, and wait to hear from them. If they have funding and they like your profile, they will write back to you, and you go about applying. And that kind of assures you of a sure shot admit. And another way could be directly applying to the departments, which is more popular in the US, where you just directly apply to most of the departments and you just count your chances. Although doing a bit of referencing, getting in touch with the professors beforehand doesn't hurt you. And to prep you up, I'm sure all of you are aware what you need. You would need your GRE, TOEFL, or the IELTS, things like that. Again, for Canada, GRE is not mandatory. It's very university specific because of COVID. In most of the US universities are done with GRE as well. So look into that. If you need to take the GRE, prepare for it well in advance. It takes time. Prepare for your IELTS or TOEFL. You would need those. Those examination comes with certain cost. Be aware of those things as well. And have your transcripts ready. Work on preparing a good CV. And you would need a statement of purpose. And that's a difficult thing. Start working on it. And tip It needs to be your own. So start working on it. It takes some time. Get on ahead with these things. And for the industry,
Sorry for the introduction, ma'am.
Go ahead.
So actually, what thing we should include in the during writing of statement of purpose?
Okay, so honestly, even I don't know. I was expecting these questions, and everybody has this question. Nobody has the proper answer to it. So your statement of purpose is something which is your own, and it shows you, it shows your personality, the kind of person you are, and what you are looking to achieve. So I found a couple of good posts in Google and on LinkedIn, and some professors shared it. So they look for people if they will fit like their research group or not. It's like your interest should match the interest of the group they are working on. So that should be there. And you write about your of course your educational experiences. You also write about your co-curricular activities and things you do beside your education, because that's what shows your personality or fit in it. When I told personality, and yes, personality does matter. Whatever career you are in, your personality is going to matter. So ensure that your part or what you are is reflected in that thing, and what you would like to work on and why you would like to work on that. Like, what's the inspiration for you to choose that particular topic or that group? Those are the things they are looking for it. And don't make it generalized. Don't copy paste it from here and there. They just know it. They get their thousands of SOPs. It need not be in very fancy English. They are okay with normal things, but yeah, it should be just strong enough, something interesting. Make it interesting to read at. Ask your friends to read it, or share it with them. Ask people and get their reviews. If it's interesting to read, then you have a good chance of getting it.
Thank you, Dee.
Yes. Guys, any more question? I took up a lot of your time. I'm so sorry about that. If you have any more questions, I will be happy to answer. I guess not. So thank you so much, all of you, for spending your Saturday evening. And what do I say? Be kind to yourself and take care of your physical and mental health. It's very important. Study, work hard, and keep dreaming. You will achieve whatever you want. You are well equipped and have all the necessary resources you possess. So dream about it, and also keep participating in talks like this and get connected. Talk and expand your network. It's very important. And learn, really learn from everyone around you.
Thank you, ma'am. It
So,
was a very enlightening and informative learning session. We sincerely thank you for your participation and wish you all the best for your future endeavors. We hope for more learning opportunities from you.
thank you so much, Obhiru, for the beautiful ending as well. Well, a happy Saturday evening to all of you. Oh, wow, that's so... Oh, I'm so happy to see this. Thank you guys for this. Oh,